All right. So coterminal angles are 360 degrees apart. So the least positive coterminal angle, you add 360 to this, and you get 493. And then you take 133 minus 360 to get the negative coterminal that's the closest to the original angle. What's 133 minus 360? 227. So negative 227. Are we good with those two? Just add 360, subtract 360. Are these coterminal? Are these 360 apart? Well, they're definitely not 360 apart. Are they 720 apart? Because if you go around once, it's 360. If you go around twice, it's 720. Well, if you add these two together, they add up to, or if you subtract them, 315.6 minus 4 minus the negative 404.4. You go plus a positive, and you get 0, carry the 1, 0, carry the 1, 2, carry the nothing, and that, and 720. Yes, they are coterminal. Okay? Because they're exactly 720 apart. Do you understand that? So they either have to be 360 apart, 720 apart, 1080 apart, 1440 apart. Okay, a multiple of 360 apart. Okay? Okay. Where is a 142 degree angle? Well, if I know 90 is there and 180 is there, where's angle 142? Well, it's in quadrant 2. Convert an angle to decimal degrees. Well, 36, we divide by 60 to convert it. What's 36 over 60? Point what? 0.6. So it's 67.6 degrees. And now if we want it in degrees, minutes, seconds, instead of dividing the decimal part by 60, we multiply it by 60. So 0.940, and my stylus stopped working. And I don't know what just happened there. .940 times 60. Somebody help me out. 56.4. So it's negative 82 degrees, 56 minutes, and then you take 0.4 times 60, and you get 24 seconds. Okay, so here you divide by 60, here you multiply by 60. Converting to radian measure, how many radians are in a circle? 2 pi, so it's 2 pi radians over 360 degrees, or 1 pi radians over 180 degrees. Okay, so 270 goes into 180, 27 and 18 times, which is, if you divide them both by 9, it's 3 pi over 2. 240, you multiply by pi, divide by 180. 24 over 18. 6 goes into each 4 and 3 times, so it's 4 pi over 3. Okay? When we convert to degrees, instead of multiplying by pi over 180, it's 180 over pi. Then we eat our pi, and we're happy. And then we take 9 times 180 and divide it by 5. 324. Now, if you have a decimal, you multiply it by 180, divide it by pi, but then you use your pi button on your calculator. Okay? So use your pi button on your calculator, round to the nearest thousandth. Thousandth is what decimal? Third decimal. And what do we get? Ooh, Mr. Bierschbach made a major mistake on this one. What did he do? Wrong. We're converting to what? Radians. What needs to be on top? Pi needs to be on top. 180 needs to be on the bottom. I was going something that doesn't look right. And it didn't. So it's 74.9 times pi divided by 180. There we go.
1.307.
There. That looks right. Now, coterminal angles when you're dealing with radians. So you take pi over 5 plus 2 pi. Well, to add these, I need a common denominator. So it's pi over 5 plus 10 pi over 5. Where in the heck did I get 10 pi over 5 from? Yeah, because I have to multiply the top and bottom of this fraction by 5 over 5. So 10 over 5 is 2. So if we add these together, we get 11 pi over 5. If we add another 10 pi over 5 to that, we get 21 pi over 5. So there's an answer. There's an answer. Well, this is the one with those answers in it. Where's the quadrant? Where's 5 pi over 6 located in? Well, some of you could look at it and figure it out. Some of you would want to convert it to degrees. So multiply by 180 over pi. Pi's cancel. And it's 150 degrees, right? Where's 150 degrees? What quadrant? 2. All right, arc length. Arc length is over on the board over there. Now, is this in radians or degrees? Radians. So you have to use the radian formula. You just take arc length S equals the angle times the radius. So you just multiply them together. Somebody take 2.3 times 113.
259.9.
So it's 259.9 centimeters. Okay. This one, it gives you the arc length, and you need to find the radius. Okay. And this is in degrees. So 26 equals 36 over 360, because this is a geometry one because it's in degrees. So you have to use the top one. So 36 over 360 times 2 pi r. Now I know 36 over 360 is 1 over 10. So I don't like fractions. I want to get rid of my fraction by doing what to both sides? Multiply by 10, and those cancel. So 260 equals 2 pi r. Divide by 2, 130 equals pi r, and divide by pi. If you divide by 2 pi without putting it in parentheses or anything like that, you're going to get the wrong answer. So what's our radius? What's 130 divided by 3.14159265? 41.2 decimal places. Okay. Sector area. Sector area is the angle times the radius squared divided by 2. The angle times the radius squared divided by 2. Well, the radius squared is 144. 144 divided by 2 is 72. 72 divided by 3 is what? 24. Yep. So we get 24 pi. And then we're to our last stuff here. Radians cancel with radians. Minutes cancel with minutes. So I'm at revolutions per hour. I take 18 times 60 divided by 2. And then whatever that answer is, divided by pi. And what do we get? So 0.9, because it's the nearest tenth. Okay, last three. The windmill for generating electricity has a blade 30 feet long. Depending on the wind, it rotates at various velocities. Find the angular velocity in radians per second of the tip of the windmill, rotating at 95 revolutions per second. It has some extra information in here that we don't even have to worry about. What's our extra information? 30 feet long. We don't have to worry about that. All we have to worry about is the 95 revolutions per second. To change it into radians per second, multiply by 2 pi radians over 1 revolution. Revolutions cancel per second. All right, so 95 times 2 pi. Okay. Now, the next one, the table saw one. You have 3,200 revolutions per minute times 2 pi radians over 1 revolution times how big's the radius? 8 inches in the radius times, now we have inches per minute. Now I got to get miles per hour. So I multiply by 1 foot over 12 inches and 1 mile over 5,280 feet and by 60 minutes over 1 hour. And then you do the math. And that thing is cooking down the road. 3,200 times 2 times pi times 8 times 60 divided by 12, hit equals, divided by 5,280, hit equals. Yeah. That'll take off a finger pretty fast if you get it in there. Okay. A printing press has a roller 12 inches in diameter. The speed of a point on the roller surface is 58 feet per second. What's the roller's angular speed? We want radians per second. So I have to change feet to inches. So I know there's 12 inches in 1 foot. And then I have to get rid of the inches. So I know my radius, my one radius is 12 inches. Oh, 12 inches in diameter, so it's a 6-inch radius. So inches cancel with inches, and now I have radians per second. So it's 116, right? Radians per second. Okay. So that's the basics of how you do the quiz that you're going to have on Thursday. Okay, Thursday quiz. And then, so we'll take the quiz the first half of class. Second half of class, we'll start on